Hello, this is Shizuri One, and today I'm going to explain my pre-assignment of the Compnet uh, class for the laboratory assignment. Yes, yes. Anyway, there's only 8 questions, so I can do this quick. So let's do it. So first of all, we got explain what routing is and how it works, and provide an example when routing is necessary. So that's very simple. So routing is a process used by other routers not other routers, to forward data packets between different networks. So basically, it's the process of sending another data of packet or whatever to sending data from that packet to another to that router to another router to like so 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 uh, routing is basically this is the router, like a router, and then this is the network, and then yeah, routing is just you doing this. It'll be routing from this router 1 to router 2 to another network. So yeah, that's routing. Next we have static. Wait, no, this first. Compare the advantage and disadvantage of static routing versus dynamic routing. So let's get to that. So static routing requires manual configuration and is stable and secure and efficient in small networks. However, it cannot adapt to the network changes. While dynamic automatic updates routing tables using protocols as RIP or OSPF, and it suits large frequent changing networks, but it does uses more CPU and bandwidth resources. So it's basically back to the benefit of well, static is you get more in control, which is security and control and safety, but it's only good for small networks and for large bandwidth. If you have like MIDI routers over here and you try to do a static routing, like I think there's like so many, like 50 of them, like that's gonna be hard. And then the dynamic is automated, so everything for this 50 routers is automated. So each connection, like there's a network changes of this is like the main network here. This is the main network, and it's basically just easy update to all of these 50 routers. While the static, it's like you can't do any of them because you gotta do open this, edit this one, open this, edit this one, stuff like that. So that's it. Okay, next, number 3 is state and explain the differences between RIPv1 and RIPv2 protocols. So, okay, here's the question. RIPv1 is a classful and uses broadcast to share routing updates without subnet information, making it unsuitable for modern networks. And RIPv2 is classless, and because it uses multicast 224.009 to be exact, and also support VLSM, which is basically this variable length subnet mask, which is a subnetting technique. So yeah, let's read that, whatever. And then allows authentication, basically just better version of the RIP. So that's it. Next is number 4. Explain in detail the roles of metric and administrative distance in the routing determination process. Include an example on how both factors are considered when selecting the best path in a complex network. So the metric represents the cost of a route, such as hop count in RIP. So the administrative distance, the AD, to be that here, ranks the reliability of different routing resources. A router selects the route with the lowest AD first, and then compares the metrics within that protocol. For example, static AD1 is preferred over RIP route because it's AD120, because lower AD is the better in this case, even if the RIP fast has fewer hops. So it's a self-explanatory, you get it. Next, number 5. State and explain the differences between configuring a static route using a next hop address versus a forwarding or exit interface. So here, a next hop route specifies the IP address on the next router. So while an exit interface route specifies the outgoing interface, the next hop route is referred for multi-access network, and access services are used in point-to-point links, for example. Okay. So this is the next hop, which is the IP route 192.22.022, and the subnet to the 5.10.0.0.2, while the IP route for an exit interface, uses an exit interface is for like this, so the serial sort of this. You get the point, right? Anyway, number 6. Identify and discuss the type of each timer in IRP with a detailed explanation of its function and role in managing routing updates. Explain when the timer adjustments are necessary to maintain optimal network performance. So RIP uses 4 timers: update for 30 seconds, and valid for 180 seconds, hold downs for 180 seconds as well, and a flush for 240 seconds. The update timer sends routing information periodically, so the invalid timer marks routes as unreachable if no updates are received. The hold down timer prevents instability, and the flush timer deletes expired routes. And adjusting these timers helps maintain stable performance. So timer matters. Time matters. What's the function of auto summarization feature in the RIP? Explain network conditions under which this feature can be detrimental and causes connectivity issues. So auto summarization allows routers to advertise only the classful network address instead of each subnet. This feature can cause routing errors in VLSM or discontinuous networks by merging separate networks into one advertisement. Therefore, it is usually disabled with the no auto summary command in classless routing environments. So, authorization, yes, you see. So, VLSM, if you forget, is variable length subnet, which is a subnetting technique for allocating IP address more efficiently. And auto summary can be shit at it, basically. Lastly, sorry for cursing. 8 is what is the function of the passive interface command in our RP configuration? Provide a specific example of when and why the administrator will need to use this feature. So lastly is this. The passive interface command prevents RIP from sending routing updates through selected interfaces while still including those networks in the routing process. It is used to stop unnecessary updates on LAN or untrusted segments. For example, a router connected to the user's PC can use the passive interface G01, G0- whatever you want to call it, to block RIP updates on the link. So it's basically a shield, so to say. So if I pull this like this. So yeah, as you can see, a router connected, so it's a router shouldn't be red. Router should be black. You see, this is a router and this is a PC. Go. So this is their connection, and then this is basically this cable right here, this connection of routing. It's a passive interface Z01. So if there's a network, let's say this is from the network, and there is an evil. This is an evil like untrusting stuff here, and they want to go to the PC. But because of this very exclusive cable called the passive interface G0-1 type, it's basically just blocked. Like they just the evil cannot get through, and then they now said like they're crying now. You get the point, right? So yeah. Anyway, that's it. That's for the final. For the final answer of the 8th. Thank you for listening. Bye bye.